Now it's time for us to dive into one of the most common loops you're ever going to see. You know, when we have whiles and do whiles, those are some great loops, but they are used in situations where we can't possibly know in advance how many times that loop has to execute. In the case of a while loop, it might not execute at all. In the case of a do while loop, it's guaranteed to execute at least once, but the number of times that either of those loops runs at maximum is effectively infinite. We just don't know how many times it's going to run. But what about those cases where I do know how many times I want to run? Maybe I want to take a certain sequence of steps a very specific number of times, like 5 times. I want to do this thing 5 times. If I know in advance how many times I want to do something, I don't have to use a while loop or a do while loop. I could, but those are not the best tools for the job. The best tool for the job is the for loop. So in case you didn't know, I'm a super RPG nut. I love tabletop RPGs. One of the most common things to do in a tabletop RPG is to roll dice. For example, you may wish to roll a stat value for the character because every character has some collection of stats. And in many situations, the stat value of a character is determined by rolling let's say 3 6-sided dice. So in other words, every stat can be a value between 3 to 18 inclusive. So how do we randomly determine that value simulating rolling dice? Because there are a few different ways to approach this, but if I wanted to actually roll dice, then I'm probably going to want to simulate how many dice I'm rolling and getting those random numbers. The first thing we're going to need is we're going to need a random number generator. And so let's make a random object that we will call RNG, and we'll just new up that object. And now that I have a random number generator, I can use that object as many times as I wish. In this case, I'm going to use it 3 times to generate a number between 1 and 6. So since I know I want to roll 3 dice, or rather I want to roll a 6-sided die 3 times, this is a great opportunity to use a for loop. I know in advance how many times I want to repetitiously do the thing. First of all, if we're going to do a for loop, we want to start with the for keyword. Now, the for loop has a different anatomy than any other loop in Java. And mostly it has to do with the for loop's parenthetical. The for loop parenthetical actually has 3 parts, not 1. You see, in the while loops that we've done before, the while and the do while, that parenthetical is used only to support the Boolean condition that determines if the loop is going to run again. But for loops don't work that way. The parenthetical is actually very different. It does have that Boolean condition. It has that loop condition that when true, the loop repeats itself. But there's more to it than just that. The first part of the for loop parenthetical is called the starting condition, sometimes referred to as the precondition. Now, all this means is that we want to set where the loop begins. You might often see an int declared here, and conventionally you'll often see it declared as int I, and the I is short for incrementation counter or iteration count or index, or even sometimes it's just I to represent a generic int, short for int. But in this case, let's be a little bit more expressive because we can name this whatever we want. Let's call this roll count, and we will start this at 1. You will often see the starting condition start at either 0 or 1. Once you have your start condition set, it ends in a semicolon. This tells the compiler and the runtime that our start condition has been declared, and this semicolon is the end of that start condition. Pretty easy, right? The next portion, the second part of the for loop parenthetical, is of course the loop condition. This is exactly what you expect it to be. It's some Boolean condition that when true causes the loop to repeat. In this case, I want to roll 3 6-sided dice. So I'm going to roll my die, my 6-sided die, 3 times. Therefore, I want to continue so long as roll count is less than or equal to 3. And finally, the third portion of the for loop parenthetical is called the modifier. The job of the modifier is to impact some portion of the loop condition such that the loop is guaranteed to terminate in the expected amount of time. or an expected number of times. Normally, the modifier impacts whichever variable is tracking the start condition, because as we modify that value, we ultimately approach some terminating value or some terminating condition. So in this case, we're going to say roll count plus plus. You will often see that the modifier is simply the variable for the starting condition increased by 1. That is the most common modifier. It's not the only one. We can have all sorts of different modifiers there. If we wanted to modify by 1 up, that's great. That's what we're doing. If we want to modify by 1 down, that's also acceptable. If you want to modify by 2s, if you want to multiply by 3, if you want to get the mod when you divide by 5, you can do all those things. All of that is acceptable so long as that logic is guaranteed to cause the loop to terminate in the amount of iterations you wish. Okay, so now that we have our for loop set up, let's do one more thing outside the loop. First, let's declare an int called stat, and we'll start it at 0. I'm doing this because I'm going to be changing this value during the for loop, and I'm going to change this value cumulatively. That means I'm going to add and add and add again. And if I declare int stat inside of the for loop, what is that really going to do? Well, every time we iterate through the loop, this stat is going to get created brand new and set to 0, so anything I did previously is going to be lost. If I don't want those values to be lost, I have to declare int stat outside of the for loop. So now that I have stat outside of the for loop so I don't lose my changes, inside of the for loop, I'm simply going to say stat plus equals, I'm going to add to it some value and then store it back in stat. And that value is going to be determined by my random number generator. I'm going to use my random number generator dot next int to determine what random int to get and add to stat. Now, if I call next int just like this, I'm going to get any number between negative 2.147 billion and positive 2.147 billion. I obviously don't want that. What I really want is to simulate a 6-sided die. That means I need this to be 1 through 6. I need the random number 1 through 6, right? So I need a random number 1 through 6. In order to do that, there is a version of this method I can call that will take in an upper bound. And you can see here it says int bound. And the description of this method says it returns a pseudo-random number between 0 inclusive, that means 0 is a possibility, and the specified value, the bound, exclusive. That means up to but not including the bound. Now this is interesting. This is going to return 0 to whatever I put in minus 1. So if I put 6 here, this is going to return 0 through 5. Now think about that for a second. This is going to return 0 through 5. Now that is still a range of 6 digits, right? 0, 1, 2, 3, 4, 5. It's still 6 unique numbers. But I don't want 0 through 5. I want 1 through 6. Now, if you understand a little bit about math and number ranges, then you know that if I have two ranges that are equal in quantity, if I have a 6-digit range here and a 6-digit range here, where the numbers are sequential, it's just the lower bounds are a little higher or lower, and the upper bounds are a little higher and lower. If they're off by the same amount, then all I have to do is add a number after the range to create what's called a shift. So what I have is 0 through 5. But what I really want is 1 through 6. Both ranges are 6 digits. It's just the lower bound of each is different by 1, and the upper bound of each is different by 1. That means all I have to do is add 1 after the number is selected, and I cause a shift. So check this out. Right now I'm getting 0 through 5. If after the number is chosen, I simply add 1, then the lowest number I'll get from this method is 0, and when I add 1 to it, it's 1. The highest number I'll get from this method is 5, and when I add 1 to it, it's 6. And thus I get a random number between 1 and 6 inclusive. So now I've got a random number between 1 and 6, which I am adding to my stat. Nice. And I'm going to do it 3 times. Awesome. You know, magic numbers kind of bother me. I don't really like magic numbers. They don't mean anything. I'm going to take a moment here, and I'm just going to say that there's an int called num of rolls. And we're going to set that to 3. And instead of saying roll count is less than or equal to 3, I'm going to say roll count is less than or equal to num of rolls. In other words, the number of rolls I wish to make, right? Then, once I'm done, let's go ahead and sys out and print our stat so that we can see the ultimate result. When I hit play, I get 10. When I hit play again, I get 9. When I hit play again, I get 8. And so you can see that every time I execute this, I get some randomly assigned number. Now, of course, I'm going to get a lot of the same numbers over and over because of statistic likelihood, because of the likelihood of rolling a 10, 11, or 12 on 3 6-sided dice is actually extremely high. Look, this time I got 17. That is statistically low. That is almost a perfect roll. That's 2 6s and a 5. But it's still possible. And similarly, extremely low numbers are statistically low. Like here's a 6. Now there are several combinations that will give me 6, but this is probably, numbers between 1 and 3 or 1 and 4 on 3 dice. There's 6 again, and here's 10. And so you can see I'm getting a different outcome each time. Now, that's really interesting and that's cool and all, but characters in RPGs don't just have one stat. They often have multiple stats. In fact, in the system that I like to play, we roll 3d6 for 8 stats. We do that 8 times. So let's see, hang on a second. So what I'm saying here is I have this process where I'm rolling a stat, right? And the way I roll a stat is I have a die that I roll and I do that 3 times. So I have a for loop to get 1 stat. Now I have 8 stats. In other words, I have a process I want to repeat 8 times, like a known quantity of times. So what I'm really saying here is, I've got this 1 stat and that's cute, but what I really want to do is I want to roll 8 stats. Normally I would have a different stat variable for each value of the character, like 1 for IQ and 1 for physical beauty and 1 for strength. But for the purposes of our demo, I just want to show that we can put for loops inside of for loops. So I can say int stat count, and let's start with the first one. And similarly, outside I'm going to declare int num of stats. I'm going to set that to 8. In my loop condition, I'm going to say that stat count is less than or equal to num of stats. I'm setting this up very similarly to how we're rolling dice. And then finally, stat count plus plus. I put some curly braces around the parts that I want to have repeat because I'm simulating rolling individual stats and I want to see those stats as they come out. I'm going to set inside of this for loop, when this thing begins, the outer for loop begins, I'm going to set stat to 0. I'm setting my num of rolls to 3. You know what? That doesn't really need to change. I'm going to go ahead and just pop that out here. And then I'm going to roll that singular stat, print it out, and then repeat the outer loop if I have not rolled all the stats I wish to have. All right, cool. So let's go ahead and execute this and see what happens. There are all 8 of my stats. I hit play again. Now I've got different stats. I hit play again. Now I've got different stats. So what I'm trying to show you here is if I'm in any situation where I know that I want to execute something a known number of times in advance of the loop executing, then I can use a for loop. Now, let's do just one more thing. What if in my RPG I want to apply damage? Like, for example, I hit an enemy with one weapon that's going, and maybe it's a massive weapon that's going to do, say, 3 10-sided dice worth of damage. Or maybe I throw a small knife. That's going to do less damage, like maybe 1 4-sided die of damage. If we have these situations where I need to deal damage and that damage range can vary depending on the kind of attack, then that means I'm going to have to be told certain things like how many dice I want to roll and how many sides each of those dice have, right? And if that's the case, that means I need dynamic input. If I need input from the user, can I still use a for loop? Think about that for a second. So what if we start from 0, right? Let's get rid of all this. And what I want to do is prompt the user for the number of dice to be rolled, and I need to prompt the user for the number of sides each die has. Now this is referring to the dice in that roll, right? And all the dice in a single roll will typically have the same number of sides. So if I have to prompt the user for the number of dice to be rolled, and if I have to prompt the user for the number of sides of each die, can I still use a for loop? And the answer is yes, I can. Because before the for loop begins, do I know what I need to know? Yeah, I've prompted the user for the number of dice. That tells me how many times to execute the loop, and I've prompted them for how many sides the die has. That tells me the number range that the RNG has to produce. So yeah, I can use a for loop here. And in fact, I probably should. So let's go ahead and write our dynamic for loop for rolling damage. First, we got to prompt the user for how many dice they'd like. So let's do string input equals, oh no. So first, let's produce our prompt, right? Let's say, how many dice would you like to roll? And then I'm going to take my string input. I'll make it equal to my input reader. That's my buffered reader up above. Dot read line, like we've done so many times before. And then I'll have an int, and we're going to call this num of dice. And we're going to set that equal to integer dot parseInt, passing in the input. Again, we've done this like a billion times. Not too concerned that you know how to do this. Now, to be honest with you, I'm just going to copy this really quick and just bring this down. I'm going to change the prompt. How many sides does each die have? Remember that die is the singular, dice is plural. I'm going to reuse input in this case, and I'm going to declare a second int called num of sides. So now I have the number of dice I want to roll and the number of sides of each die. Now that I know that, I can create my for loop. Now, how do we get started? We need a starting condition. Let's do what we did before. Let's do int roll count, and we'll set it equal to 1. Now, when do I want this loop to continue? Well, I want this loop to continue so long as roll count is less than or equal to the number of dice I'm trying to roll. So if they want to roll 4 dice, this will continue so long as roll count is 1, 2, 3, or 4. Finally, at the end of each loop, I want to increment my roll count by 1. All right, so now that I have my starting condition, my loop condition, and the modifier that runs at the end of each iteration of the loop, we need to figure out what goes inside here. If at the end I want to report the total damage, then I have to consider where the damage int needs to be declared. If I declare it inside of the for loop, remember, if I do this, if I say int damage equals 0, then that means that every time this loop repeats, damage gets set to 0 again. And I'm not going to be able to track how much damage I did. Also, in addition to that, if I declare damage inside of the loop, it only lives inside the loop. So if I try to print something like total damage, and then try to concatenate that onto the string, I won't be able to see that variable. It's stuck inside the loop. It only lives for the lifetime of the loop. So how do we fix this? Well, if I need to use it outside the loop, I need to declare it outside the loop. So now that it's outside the loop, I can modify the damage variable, and I'll be able to print out the total after the loop is done. So what do? Damage plus equals, and now what's going to go here? I know we're going to call RNG, and we're going to call next int. But what's our upper bound? What is our maximum value here, our exclusive upper bound? Well, it would obviously be the num of sides of the die. If I'm rolling a 6-sided die, this would be 6. If I'm rolling a 10-sided die, this would be 10. But remember what happened previously? Whatever I put here is going to result in 0 through this number minus 1. That'll be the right quantity of numbers, but it's not the right range. So to fix that, I'm going to adjust it by 1. I'm going to cause a shift of 1. And that means that when this returns 0, it'll ultimately be a 1. When this returns if num of sides was 10, then the maximum that this method would return is 9, but when I add 1 to it, that 9 becomes 10, and thus I get 1 through 10, just like we did earlier. So now I've got my damage plus equals this range of numbers, right, whatever number of sides is, plus 1, so I get the right range, and I'm going to do that the number of times that they gave me dice to roll. All right, let's see that in action. Hang on. Let's hit play. How many dice would you like to roll? Let's do what we did before. Let's do 3. And how many sides does each die have? Let's do 6. And I get 13. Right? I can do this again with the exact same values, and we get a different total outcome. But I can also do different values. I can say, well, let's do 2 dice at 4 sides each. And I get a low but still correct value. And then maybe we do something bigger. Maybe we do 3 dice at 20 sides. And I get a number of 35. And so we could do this as many times as we want. And using this little for loop, we've created a simulated dice roller. And that's kind of awesome. So anytime that we know exactly how many times we wish to iterate over a process, we should be using a for loop. Yeah, I could do it with a while loop. But in order to do it with a while loop, I'd have to use a counter. And if I'm going to use a counter, I'm basically just writing a for loop in the first place. So whenever you know in advance of the loop executing, whether you're told the value or you can mathematically derive the value, if you know how many times that loop needs to execute, you need a for loop.